You've built a documentation search system that works perfectly for simple queries until someone asks, "How do I configure authentication with rate limiting?" Your system returns 3 chunks: half a config example, part of an unrelated API endpoint, and the middle of a troubleshooting section. Don't end up here after many long nights. Here's what actually works and what breaks production systems. Before I forget, stick around for a special surprise at the end of this video. Are you excited? I'm excited. Can't you tell? This isn't just poor search results. It's broken information architecture. Most teams chunk documentation by arbitrary token limits, treating technical content like blog posts. Traditional approaches like 512 token fixed windows and sentence-based splitting fail because they ignore semantic boundaries and code context. The cost? Developers abandon your docs after failed searches, support tickets increase, and your carefully written documentation becomes effectively invisible. Retrieval augmented generation solves this by understanding content relationships before chunking. Instead of blindly slicing text, RAG analyzes semantic boundaries and preserves contextual meaning. The key breakthrough: intelligent chunking that respects documentation structure while maintaining retrievable units. This enables precise information retrieval while preserving the logical flow that developers need. Recent research on semantic chunking demonstrates significant improvements over traditional methods, with max-min semantic chunking achieving superior performance with average adjusted mutual information (AMI) scores of 0.85 compared to fixed-size approaches. Stack Overflow implemented SemanticSearch on their platform, configuring their embedding pipeline to consider questions, answers, and comments as discrete semantic chunks, leveraging the highly structured nature of their Q&A pages. Think of smart chunking as content-aware segmentation. Your documentation goes through semantic analysis, then boundary detection, finally producing contextually complete chunks. Each stage preserves meaning while optimizing for retrieval. Semantic chunking uses embedding similarity to find natural breakpoints, maintaining topic coherence across sections. Fixed window chunking splits text into uniform 500 token segments, regardless of content structure. This approach achieves consistent chunk sizes, but frequently breaks code examples mid-function and separates related configuration steps. Research shows this method can lead to context loss when semantic boundaries are ignored, as it may cut through critical sections. Semantic chunking analyzes content relationships using embedding models to identify natural topic transitions, with research showing this method achieves higher AMI scores compared to fixed approaches. The real game changer is preservation of logical relationships. Configuration examples stay with their explanations, troubleshooting steps remain sequential, and API endpoints keep their parameter descriptions intact. Sliding window chunking adds overlapping context between chunks, typically 20 to 30% overlap, ensuring critical information spans multiple retrievable units. This overlap ensures that contextual information at the boundaries of chunks is not lost during chunking, thus improving the chances of the right information being retrieved during semantic search. Understanding effective chunking requires 3 key insights. First, semantic boundaries matter more than arbitrary sizes. Break content where topics naturally transition, not where token counts reach limits. Second, documentation context differs from narrative text. Code examples, configuration blocks, and step sequences need structural preservation. Third, retrieval units should answer complete questions. Each chunk must contain sufficient context to be independently useful without requiring adjacent chunks. Research demonstrates that the choice of chunking strategy can have significant impact on retrieval performance, with some strategies outperforming others by up to 9% in recall. Recent evaluations show that Colbert-based embedding with sentence splitting proved to be the most efficient method of improving result accuracy and relevance, with an average performance advantage of about 10% over other methods. Smart chunking transforms fragmented documentation into precision-targeted knowledge retrieval. You go from scattered search results to contextually complete answers. MongoDB's implementation of their documentation AI chatbot showed that adding metadata to chunks before creating embeddings greatly improved the quality of search results, demonstrating the importance of thoughtful chunking strategies in production systems. Your next step: Audit your current chunking approach with a sample of real user queries. Test different semantic-aware chunking strategies against your most challenging documentation sections. Focus on preserving logical structure and maintaining complete context within each chunk rather than arbitrary size limits. If you found this content valuable, be sure to like and subscribe to stay updated with the latest in the AI space. Looking to level up your skills, bring real value to your organization, or finally build your first AI application grounded in truth, whether domain-specific or general? Head over to our site and sign up for the Production RAG Foundations course. This isn't a self-paced, watch-and-forget kind of course. It's hands-on, contains notebooks that can be used in production environments, and designed to help you build real production-ready retrieval-augmented generation systems. You'll go beyond surface-level tools, diving into vector databases, embeddings, chunking strategies, and more, without falling into the trap of bloated, over-engineered solutions. Seats are limited and spots are filling fast. Early signups get access to our private community and let you strut your stuff across the leaderboard with AI competitions that will help build your portfolio. Check it out. We'd love to have you on board. Now for the best part.